Welcome to helpyourmath.com. In this video we're going to be solving for x by using these right triangles and the properties of right triangles and simplifying our answer once we solve for it. Remembering that we're using Pythagorean theorem when we're using right triangles for each one of these cases. The hypotenuse is always the longer side, which is opposite to the right angle, and you can tell the right angle by the little box in the corner of the triangle. In this case we're using Pythagorean theorem, which tells us a squared plus b squared is equivalent to c squared, where c is the hypotenuse and a and b are any of the two legs of the triangle. And so we can assign any of the values to a and b for the legs of the triangle, whereas c is always the hypotenuse opposite to the angle of the right angle. So let's substitute in our values and solve for x. So our a value here is going to be 2 squared plus b, which is x squared, equals c, which is 8 squared. This becomes 4 plus x squared is equivalent to 64. Now our next step is to isolate our x squared term, in which we have to subtract the constant with the variable away from the variable. So we're subtracting 4 to both sides using the additive inverse. These will cancel out and we're left with x squared equaling 60. To solve any squared variable, what we need to do is take the square root of both sides. And in this case, we're going to be taking the square root of x squared while taking the square root of 60. And in this case, we don't have to worry about the plus or minus for the square root because this is a triangle with always positive values, right? And the hypotenuse always has to be a positive value. In fact, all values of this triangle have to be positive. And so we get here x is equivalent to the square root of 60. And we can't take the square root of 60, but what we can do is break down the square root of 60. To do this, what we want to do is find a perfect square that makes 60. And the largest perfect square that we know that makes 60 is the value of 4. Because 4 times 15 gives us 60. And 4 is the only perfect square that's a factor of 60 as well. And so we're going to get the square root of 4 times the square root of 15. And this then becomes x is equivalent to 2 radical 15s. That's our solution for the first value of x. Let's move on to the second equation, the second triangle actually. Again, the legs of the triangle are your a and your b, whereas your hypotenuse, the longest side, which is always opposite to the right angle, is your c value. And so again, we have Pythagorean theorem, a squared plus b squared is c squared. And we're substituting our values in. We get 3 squared plus 6 squared is equivalent to x squared. And here we get 9 plus 36 is x squared. And so here we're going to have 45 when we add 9 plus 36. And that's equivalent to x squared. Let's move the x to the left-hand side here and just flip these over. X squared is equivalent to 45. What we're going to do to solve it is take the square root of both sides. And so we get the value of x is equivalent to the perfect square that makes 45 now is, if you take 9 times 5, you get 45, and 9 is a perfect square and 5 is a imperfect square. So the largest perfect square is 9, and we're going to have 9 times 5 when we break it down. And finally we have x is equivalent to 3 radical 5s. Let's move on to the next one. Again, the legs of the triangle are adjacent to the right angle. We can tell that by the little box that looks like this. It's a little square in the corner of the triangle. And we know that this will be A, this will be B, and finally our third side will be C, which is always the hypotenuse opposite to the right angle, right? And now we have A squared plus B squared is C squared. Our A value is just x being squared, our B value is just 5 being squared, and our C value is 7 being squared. So now we're going to take x and square it, plus 5 being squared is 25, and 7 being squared, that's a 49. Let's isolate our x squared term by subtracting 25 to both sides. This makes these cancel. We are left with x squared on the left. On the right hand side, we're left with 24. Our next step is to take the square root of both sides. We have the square root of x squared, the square root of 24, and x is equivalent to the square root of 24. Now I haven't actually shown you guys how to break these down best so that you can find the perfect square. So let's start with 24 here. When breaking down 24, what we want to do is use prime roots. and break them down to as many prime roots as we can. So we know 2 goes into 24 since it's even, and 2 times 12 makes 24, where we have one prime number. So we know 1 base of 24 is 2. Again, we're going to break this again down using a 2 since it's a prime, and 2 times 6 is 12. And to make 6, we know we could use 2 times 3, which gives us 2 more prime factors. And so our prime factors are 2 and 3 for the product of 24, and 2 to the 3rd power makes 8 times 3 makes 24. And the perfect square in this is any even powers of 2. So if we take 2 to the 3rd times 3, and we separate just the even power of these by separating this to 2 to the 2nd times 2 times 3, we know that this is the perfect square, because 2 squared makes 4. And 2 times 3 is just 6. And these are the roots of perfect and imperfect roots that make 24. And then we just put each in a square root. Besides doing it this way, there's one other way that we can do this. And to break down the 24, what we'd have to do is take a list of all the perfect squares that we know possible. So we have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, and 5 squared, which is where I'll stop, is 25. The reason why I stop here is 25 is bigger than 24. So if it's a factor of 24, it has to be smaller than 24 as a perfect square. The biggest number here on this list that makes 24 is actually 4. So I could also figure out my factors for the perfect square this way, which I know 4 times some number is 24, and 4 times 6 makes 24. So I'll take each of these factors and put them in different radicals, and take the square root of whichever one I can, which the only perfect square is 4 because it's 2 squared. So the square root of 4 is then 2. And then my x value then becomes 2 radical 6s. And that's the way to break down the square root. Once you get to these, if you ever get or encounter them, like in the case of 60, we look for the largest perfect square. The next term here makes 36, then 49. You keep looking. Once you find it, use that, break it down, and take your perfect square. Thank you.